So we want to wrap up our unit at the end here, and we want to take a look at exponential and logarithmic functions. What do they look like visually? And to do that, we're going to use our calculator to assist us with that. One of the things we do need to know about these functions, and we've studied this in Algebra 2, but there is something called an asymptote for these functions. And depending upon which one, we want to make sure we can identify it. But they're, oh geez, holy buckets. First of all, that's the wrong color. And secondly, that's super big. So asymptotes occur either horizontally or vertically. With exponential functions, we have horizontal asymptotes. These are lines that, these are horizontal lines that as x increases or decreases, the y value approaches this number. Logarithmic functions have asymptotes also, but they're vertical asymptotes. And a same idea, but reversed. As y increases or decreases, the x value approaches this number. And so we want to just make sure we understand where these are and how they occur. So first of all, horizontal asymptotes, we're going to use a dotted line to represent these areas on the graph for exponentials, and we're going to use a dotted line but make it vertical on logarithmic functions. I have two examples here. Here's what I'd like for you guys to do is on this first example, this is an example of an exponential function. This is kind of what it's going to look like on your calculator. And I'm going to graph what the asymptote is going to be and where it's going to be. So it's going to be this horizontal line somewhere where this, as the x decreases, goes this way. The y value approaches. In this other graph, this is more of a log graph. And oh, one more thing. The equation of this line, because it's horizontal, this asymptote, the equation is going to be in the form of y equals, in this example, it'd be 3, but maybe we'll say y equals any number. That's the equation of a horizontal asymptote. In a logarithmic function, this is as y increases or decreases, the x value approaches a certain number. And we can see from this particular function, looks like the x value is getting closer and closer to +2. So that would be the asymptote here. The equation of vertical lines is x equals a number, any real number. So in this problem, it would be x equals +2. We'll get into some very specific examples in a little bit. So what we want to do is we want to use your calculator. We want to see where these are at on the graph. We want to have an idea of the asymptote and then plot a couple points. I do have 3 examples for us. I'm adding an example to our notes. Here's our first example. It says graph this function on the axis below and then plot the asymptote and any 2 points with whole number coordinates. Okay, so I'm gonna show you how to do that. First step for doing this is understanding that this is an exponential equation. Okay, so exponential equations have horizontal asymptotes. That horizontal asymptote is in the form of, we talked about it on the previous slide, is y equals, we're going to find what that number is. And I'll show you how we're going to use our calculator to do that. So on your calculator, a couple things. Let's pull our calculator up here. So first thing I want you guys to do is on our calculator, do me a favor, hit zoom. Well, first of all, hit y equals. When we hit y equals, let's clear off anything we have in here from previous courses. The second step, hit zoom, and zoom is going to adjust our window size. And right now I want the window set at 10 units in every direction. That's what we call the standard window. That's number 6 here. So hit number 6. Okay, well, let's go back to y equals. What we're going to do is we're going to type in this function we see here. Oh boy. Lost my calculator. Sorry about that. minus 2, parenthesis, 0.5 or 1/2, whatever you want to use. 1/2 is a rational decimal. Exponent is x, and then we want to go plus 4. Okay, second thing we're going to do, we're going to hit graph. Let's just take a peek at it. So here we go. This is my exponential function. I need to find a horizontal asymptote somewhere. It looks like there might be one right here. This is like the horizontal line. Now, to know exactly where that is, the best thing to do, and especially to plot any two whole number points, is instead of hitting graph, just get an idea where it's at. It's going to be here at somewhere like maybe 4-ish. But if I hit second graph, that's going to give me a table. In this table of values, I can scroll up or down. The blue values are the values for this particular function. So it looks like I can get some whole number points here, and I'll maybe jot down a few of these. Actually, I'm just going to take a screenshot of this. You can scroll up and down. I'm going to paste that right here so we can talk about it. So in this particular function, as x increases, you can see what's happening here as x increases, and that's as we go down this list here. These values over here get closer and closer to what number? It looks like they're getting closer and closer to 4. Well, eventually your calculator, if you scroll down enough, that value will turn to 4. That's just because the calculator is rounding. But it technically will never, ever be 4. It'll just be 3 point something, something, something really long, closer and closer to 4. So that is where we're going to put our asymptote. Our asymptote for this particular problem is at y equals 4. And so I'm going to go to 4. I'm going to put up my horizontal line like this. And then I'm just going to plot some other points. Let's plot this one, -1, 0. Let's plot another one, 0, 2. We can do as many of these as we want, 1, 3, and so on and so forth. So as we do that, this thing gets close to it. And then this thing goes this way. There we go. Let's see how to graph a logarithmic function. Okay, some of the things that we know about logarithmic functions are, we know that they have vertical asymptotes. That's what we learned. They come in the form of x equals. There are these lines that look like this. Again, we're going to use technology. I'm going to show you how to type in a log with base 4, and then we're going to see what that graph looks like. Okay, let's grab our calculator again. Let's clear out. Let's go to the y equals. Let's clear this window out. And so let's just go -3. And then we're going to go log base 4. So we don't want to just use the log button here because that's the common log. That's base 10. Instead, find the other bases underneath math. And you need to go down here in this column. It's after what you see here. It's this one, log base capitalized. So letter A, I guess. If you hit enter there, it'll allow you to change the base to 4 or put any base you want in there. And then here we can go x minus 2. And then let's go outside of here. We'll go plus 3. Okay, let's take a peek at the graph. So we're going to see this graph here. Remember, there's some sort of, as y increases or decreases, there's this value for x that it approaches. So it's somewhere here. It looks like it's around 2, if I had to guess. Best way to look at that is our table. And in the table, as y decreases, I'm going to show you. I'm going to go like this. Give me 1 second here. All right, let's grab a screenshot of that. And then let's paste it right in here so we can talk about it. So, that being said, we have, looks like as y increases here, y is getting larger here this direction, it gets closer and closer to this number. What number for x is that? That's 2. Actually, at 2, it becomes an error. So I want you to think of it this way. Well, why does that happen? So that happens because I have 3 log base 4 to the 2 minus 2 plus 3. Well, log of 2 minus 2, that's 0. 4 to what power? If I just look at this right here, 4 to what power is 0? There's no such thing. That can't happen. This will never happen right here. And because of that, that's this error issue. And that error occurs, that creates this asymptote. I'm going to draw my asymptote. X equals 2, is it? Now I'm just going to plot some whole numbers. So I'll plot this first one, 3, 3. Then I'll plot, what else do we got? We got 6, 0. Is that what that one is? 6, 0. Is there any other whole numbers here? Let's grab, see if there's any more. That's kind of getting a little wonky there. So let's just let me get another idea of what that might look like. Oh, there's another one, 18, negative 3. 6, 0 is probably a fair one to use. 6, 0, and so on and so forth. This thing comes here. It gets close but doesn't touch, and then it goes down in that direction. Last but not least, let's try this problem here. Okay, I want you to add something for me. Let's just keep this super simple. Let's go this like 2 to the power of x plus 3. You can try this one. You can hit pause. You can try the example if you don't need any more work. One more for you. This right here is exponential. Because it's exponential, I know the asymptote is y equals. I'm going to graph this, use my calculator to see that. I'm going to go 2 to the power of x plus 3. Clear off this stuff. 2 power of x plus 3. Let's hit graph. Let's take a peek. There we go. I can kind of see that asymptote. The horizontal asymptote is like at 2 or probably 3 here. I can look on my table to help me with that. So let's go down just a little bit. I think it occurs at 3. Let's see. And remember, I'm looking at the y values here. Definitely looks like it's getting closer and closer to 3. And that's as the x values decrease. Let's just put that over here. That can give me a couple whole numbers. Then you can graph it. All right, so y equals, this is getting closer and closer to 3. Y equals 3. That's this line right here. And then let's use a different color to graph it. We'll graph a couple, let's see, 0 and 4. And then we got 1 and 5, 2 and 7. And then here it gets close to it, but never physically touches it. There you go. Well, our final problem we are going to look at here is a problem that involves using technology and graphing a log graph. It's a little bit trickier, and I'll walk you through it. A couple things we need to know about a log graph. A log graph has a vertical asymptote. It has some points, and then the line for end behavior. One side, it goes almost vertical, and the other side will either point up or down. So to do this problem, start off by typing it into your graphing calculator. And we're going to plot points. We're going to plot at least 4 of them. So the best bet is to go second graph. And then let's just grab some whole number points. -4, -5. I'll start with that. And what else we got? -3, -4. And then -1, -3. And 3, -2. All right, so that's at least 4. 1, 2, 3, 4. That's about all the whole number of points I see for right now. We can always find more. But let's just let's just get a look at what this graph is and what it looks like. So this graph, it's going to go almost vertical right here. So this vertical asymptote is close to this -5 mark. And the best way to look at that, like I described from the previous page, is to go where x is -5 and it says error. That means there is a vertical asymptote there. And let's go back to our graph to see what it looks like. And then this arrow points up as it goes to positive infinity. This end behavior points almost vertically down, but make sure it does not cross over the vertical line of x equals -5. So on your graph, you hit done plotting points. We're going to connect these here. So we'll just draw this carefully. And then as these points go, I'm going to continue until I make an arrow. Now, if I don't want to go too steep here, I want it to match this graph over here. And then I also want to do the same thing here. But remember, it's almost vertical at -5 and it never crosses this line. So as I extend this, be very careful that you get close to it, but you are not going to cross it. All right. So, and if it doesn't like that particular line here, it'll actually tell you in the solutions. So if I submit it here, it'll tell me, obviously this means I got it correct. But down here, it shows my graph that I plotted, and it shows the dotted line is the correct version. So I'm pretty dang close. This would mark it wrong if my arrow crossed over this -5. It also would mark it wrong on this end behavior if this pointed up, like above the x-axis. So we want to get it very close to matching this. And that's it.